In this video, we will be seeing operational amplifiers and some basic concepts of it. So in today's world, we use digital computing systems. So way back in 1940s, we were using analog computers. Right? So in analog computer for performing mathematical operations, we used operational amplifiers for that. So these analog computers uses operational amplifier to solve equations using voltages. So now let's see what is and what does an amplifier mean. So let's suppose this black box contains an amplifier. So if you have some input signal like this, if this sine wave is the our input signal, then you got some scale of the sine signal, right? Here we have the different sine signal. Here we have some output, and the input and the output signal is amplified of the input. So that is the work of an amplifier. So using operational amplifier with resistors and capacitor, you can build circuits for performing integration, differentiation. You can perform addition, subtraction, and you can also solve some dynamic system models. Like if you are reading some real-time data, let's suppose this is a sensor, and you are reading some real-time data from the environment, and you are performing some mathematical operations on that. So that we called it as solving dynamic system models. So as I said, operational amplifiers are used for performing mathematical operations. So let's suppose you have some inputs here, then you can perform some mathematical operations like addition, subtraction, integration, differentiation, and here you get some output. Now let's see the symbol, the standard symbol of an operational amplifier. So the standard symbol is like a triangle here, and here you have three terminals here, the input one, input two, and the output, right? So the input 1 is denoted as plus and the input 2 is denoted as minus. So why this plus, what does this plus and minus signifies, we will see later. So the main advantage of operational amplifier is that we have two inputs here. So in BJT and MOSFET, we had only one single input, and you in BJT and MOSFET amplifier you get one single output. So in operational amplifier you have two inputs, and on the basis of the two inputs you can perform some mathematical calculation if you want to add some input 1 and input 2. So you can perform that mathematical operation in using operational amplifier, and you get some output based on that. So next part is we have some standard ICs of operational amplifier. The IC741 is the most standard used in laboratories for experiments. Next we have LM358, LM324, and OP70. LM324 is a dual channel op-amp, and OP70 is precision op-amp. Like you can perform precision calculation with OP70. The next we have the schematic diagram of an operational amplifier. This schematic diagram is of 741. And inside this you can see some transistor here, like it consists of many transistor and some resistors, and you can see some capacitor here. So this is what inside an operational amplifier is. So here we have the three main important terminals, that is the you can see here the name is given as non-inverting input. Here at pin 2 the name is given as inverting input, and here we have some output. So let's see what do you mean by inverting input and what do you mean by non-inverting, right? So let's see what are the terminals we have in operational amplifier. So here we have mainly three terminals. This is, as I mentioned, this is input one. This input one is called it as non-inverting, and it is denoted as plus. And the input two we have inverting input, and it is denoted as minus. And here you get some output. This is the output here. Let's say the output is V output, which is measured with respect to ground, and these two terminals denotes the power supply given to the operational amplifier. So that is Vz plus and Vz minus. So let's see what do you mean by gain of an operational amplifier. So A naught is the gain of operational amplifier. So A naught is the open loop gain, right? So here what do you mean by open loop then? So if the output of the operational amplifier is not fed back to the input, that we call it as open loop gain. So an operational amplifier, the open loop gain is denoted by A naught. So for an ideal operational amplifier, the A naught value is near to infinity. And for a real amplifier, that is the 741 operational amplifier, the A naught value is near to 10 to the power 5. Like for the IC 741, the A naught value is near to 10 to the power 5. So let's see how do we calculate the V output. Here is the equation for calculating V output. So the V output is basically the difference between the non-inverting and the inverting voltages times the input. That is the V output is equal to V in plus minus V in minus times A naught. Now let's see circuit using the let's say the non-inverting circuit using operational amplifier. So let's suppose you have this operational amplifier here, the non-inverting terminal here as the inverting terminal, and here is V output, which is measured with respect to ground. And let's suppose you feed V1 here, and you and this second terminal is grounded. Now, so the V output is equal to V1 minus 0 times E naught, right? So V output is equal to E naught times V1. So if you see the graph of this V output with respect to the V1, so this is a straight line, right? The V output is directly proportional to the V input, and the slope of the graph is V A naught. And you can see you can see here if V1 is positive, then the V output is also positive, and if V1 is negative, then the V output is also negative. So that is why we called it as non-inverting. So it does not invert the sign of the voltage. Now let's see the inverting circuit using operational amplifier. So let's suppose this is your operational amplifier, and here is your V output, which is measured with respect to ground. And let's suppose now you feed the voltage, let's say the V2, to the inverting terminal, and the non-inverting terminal is grounded. Here the equation, like the V output is equal to 0 as the non-inverting terminal is grounded, minus of V2 times A naught, right? So V output is equal to minus E naught times V2. Now if you plot the graph here, then you get a straight line with a negative slope here. This is your straight line, and the slope of this is minus E naught. So this circuit is called as inverting, as because if you give if V2 is positive, then you get the V output as negative, and if the V2 is negative, then you get V output as the positive. That's why we called it as the inverting circuit. So summarizing this lecture, we have seen what are operational amplifier. Then we have seen why we use operational amplifier, like the use of operational amplifier. Like you can perform mathematical operations like the addition, subtraction, integration, differentiation on inputs, and you can get some output. Next, we seen the inputs, the symbol, and how why we have two terminal, and what is the advantage of having two terminal in operational amplifier. Next we have seen some standard IC and the schematic diagram of operational amplifier. Next, what are the standard input, like the input 1 and input 2, what we call it as the input 1 as the non-inverting input, and the input 2 as the inverting input, and you get some V output voltage, and the equation of the V output is equal to V in plus minus of V in minus times the A naught. Next, what we seen is this like the non-inverting input circuit. So this is the non-inverting input circuit. Here the graph is a straight line with the slope A naught, and in inverting circuit the graph is uh, a straight line with the slope minus A1. In non-inverting circuit, if you supply positive voltage, you will get a positive, like the same as the sign of the input voltage. But in inverting circuit, the sign of the voltage will change. So that is it. Thank you.